So this is part 2 of problem number 3. So for part 1, we solved and we were able to find that our RT, our R total, was 3 ohms. So we're going to fill that in here for 3 ohms. Okay, let's look at the rest of this. We have R1, R2, R3, and R4. So 6, 12, 36, 18. 6, 12, 36, and 18. So I put in all my resistances here. My voltage is going to be 12. And since this is a parallel circuit, the voltage is the same at all points. Okay, we're going to set this up once because we're solving for I for all of these, so it's the same formula. We know that V, let's just look at 4. V4 is equal to I 4 R4. V4 equals I4 times R4. We're solving for I, so we're going to divide both sides by R4. So we get I4 is equal to V4 over R4. And same thing for I3 is equal to V3 over R3. I2 equals V2 over R2. And I1 equals V1 over R1. So let's just plug them in. I4 is 12 volts divided by 18 ohms. I3 is 12 volts divided by 36 ohms. I2 is 12 volts divided by 12 ohms. That one's just 1. We don't have to do any math. And then I1 is 12 volts divided by 6 ohms. 12 divided by 6 is 2 amps. So here we just have to do the other ones. 12 divided by 18 gives us 0.67. I3, 12 divided by 36, that's a third, so it's 0.33. So we have I4, which is 0.67, 0.33, 1, and 2. So if we add these together, these two would add up together to be 1. 1 plus 1 is 2. 2 plus 2 is 4 amps. So if we check, 3 times 4 gives us 12. 6 times 2 gives us 12. 12 times 1 gives us 12. 36 times a third, 0.33, gives us 12. And 18 times 2/3 would give us 20 or 12 volts. So this is correct. This works. One way to check for I total, it was I1 plus I2, I3 plus I4. Or if we want to write it out, just to prove this one here, it should be equal to 4 amps plus 2 amps plus 1 amp plus 0.33 amps plus 0.67 amps. So that's the equation if you want to write it out that way. Or we can just know that this one is equal to all the columns after it.